How temperature changes Maxwell-Boltzmann? And I think on the practice test, there was a question about it as well. So in the rates worksheet, the sheet you got today was changing the Maxwell-Boltzmann distribution with a catalyst, but then the temperature one was 6.5, the very first note. So then we did 6.1. Which was the majority of the calculations. You had to do, this one had stoic. Just straight up calculating rate. So the first question on the review, I think, is just calculating rate. And then we had to do slope. So slope was rate because it was y2 minus y1 and x2 minus x1. That's how they're related. So we did two kinds. You don't have to draw your own graph. I think on the practice test, it makes you draw the graph, and then you just have to interpret it, okay? So there's two kinds of rates that you're going to calculate, average or instantaneous. If you've already taken functions, you might call this AROC or IROC. It's the same deal. Okay, so average, you're given the interval. You don't even really need to draw the secant. It's pretty straightforward, but it's draw a better secant than I did. You just don't want it to cross the line. Same thing with a tangent. A tangent is a little bit more annoying. So, pick a point. That was not a good tangent. Maybe like that. So a little bit more estimation with a tangent. So I'll accept a variety of answers within reason. Can you leave a number for the rate of reaction negative? No. Okay. So there were a few ways we handled that. You could either just drop the negative. Most students prefer to write a sentence. Therefore, the rate of decrease was. but please don't leave your reaction rate number negative. And then the last one of the other things that we did in this section, which was one of the ones that we didn't have to do math for, was the expression. So we're going to write them as rates of change. And I don't care if you pick what it doesn't matter whichever one you want. You could pick a reactant first, the product first, but you have to, whatever you choose, you write that expression in relation to whatever you've written first. So we drew the skeleton for it first. Say reactant, whatever. Reactants have a negative rate of change. So either make sure your negative sign is directly in the middle or use brackets. Sorry. Oh. Products then are positive. They're going to be produced over time. And then, of course, I'm not even going to call it hard. The less easy part to this is that you have to take into account the coefficients. So that was where maybe you were going to do a 2, maybe you were going to do a half, those kinds of questions. So the review worksheet does sort of go in order. It's got collision theory stuff, calculating rate, then doing expression, then doing stoich. It does make you draw the graph. Okay, so it does, the first section is mostly these two so far. There is a graph on the back as well, so you can get more practice in case you haven't taken functions yet, you don't know a lot, maybe you're not uncomfortable. What's the word I'm looking for? Unsure about average and instantaneous rate. There's lots of ways to practice, okay? And then over here is a question about a Maxwell-Boltzmann distribution and what happens when you change temperature. So in the textbook questions, I think there's a chart to do the next thing we're going to talk about, like to find the rate law. Okay, so make sure it's not just on this sheet. So this sheet really is kind of limiting how much review you really should do if you want to be good to go. I mean, you get your notes, so it's up to you. But there's a chart back here, okay? And there's one, I can see an answer here. It's in the textbook as well. And remember, the solutions are online for this, okay? Now, and you're going to have all afternoon, and then you can ask questions tomorrow morning too. Okay, so next we did rate law and reaction order. Yeah. Yes. But the solutions are a separate file. Sorry. Again, why didn't I fix it? I don't know. So for the rate law, you only include the reactants. So we did talk today that there should not be more than 3, but there could be 1, there could be 2. So this is unlike what we did today. However, you have to be given the chart, right? So it's sort of obvious that you're given a chart like this, and I showed you 2 ways. You could write what you were doing, like which trials you were using right on the chart, or you can write it. We wrote it out as well, like between 1 and 2, between 2 and 3, whatever. So you have options there, but make sure you do show your work. So then you have to figure out the exponents for the rate law. Then you could be asked about reaction order. But once you have the rate law, the reaction order is straightforward. So for the reactants, it's just their exponent. So when it talks about like what's the reaction order with respect to each reactant, you just look at your rate law. So let's say you're unsure and you're like, I'm not sure if these are the right exponents. If this is like part B or something, then just use your rate law because I won't take marks off twice, okay? And then same thing with overall. Reaction order, you just have to add the exponents. So whatever exponents you have, just add them together. So then we had to calculate K, which in itself isn't difficult. However, you have to make sure that that's where we had to cross stuff out and try to figure out the units for K. And then the other weird thing too is interpreting the rate law. So like if you double 1 and then you have to do it to that exponent. So those questions, I believe there's maybe one in the homework, but there's also one on the worksheet from today too. So there's a question on the review sheet. A question, is there one on the test? No, but okay, so lots of chance for you to practice. Okay, and then what we did today. Okay, so we revisited potential energy diagrams. So if you have a mechanism, there's more than one step, more than one peak. Make sure the slowest step is the biggest peak. Know the general location activated complexes, reaction intermediates. Again, you're not going to have to try to make those up or anything like that. Now you can write the rate law using the slow step, and the coefficients become the exponents. And then the 3 criteria for determining whether a mechanism is reasonable. When you have a catalyst and a potential energy diagram, it sort of relates to the mechanism part. You're going to a catalyst offers an alternate mechanism, so more than one peak and lower activation energy. The reaction intermediates versus catalyst, is it consumed and then regenerated like a catalyst, or is it produced and then consumed like a reaction intermediate? And then for Maxwell-Boltzmann, the threshold energy is going to be lower. And then we just did some definitions: homogeneous catalyst, heterogeneous inhibitor. Okay, so I think you have lots to do. So I'm here for you if you have any questions.